Let's get right to the point. At the end of 2024, I had the urge to move my Steam library into the living room. After an unsuccessful and rather feeble attempt at using a Mac Mini as a companion to my PC, I finally caved in and decided to move back into an ITX case, giving me the power I sought while better matching the rest of the living room aesthetics. That's all fine and dandy, but the experience wasn't complete. Living room gaming requires a certain level of laid-backness. In particular, I wanted to be able to pick up a controller, pledge my allegiance to whatever corporate overlord's gamepad I chose, and watch the small but powerful box boot up. My AV receiver and TV to react to it, Windows 11 to welcome me with open arms, and my Steam library to launch into the familiar big screen UI I've gotten to know and love on my Steam Deck. Did I succeed? To my own disbelief, yes, and even better than I had anticipated. Before we get there, just for your convenience sake, this video is split up into 3 main chapters, each covering one part of this endeavor. First is the power on sequence, then how to get Windows 11 to launch straight into the desktop without having to log in, before figuring out how to get the PC to send HDMI CEC signals so the connected AV receiver and friends realize it's time for action. Feel free to jump to the one that interests you most. Oh, and one more thing. I am limiting my entire project to Windows 11 and regular Steam, but there are alternatives out there that might make more sense depending on your hardware and needs. For example, I recently installed Bazzite on my Legion Go and I've been very happy with it. Bazzite is basically SteamOS that you can install on other hardware. Currently there are a number of handhelds and laptops supported, as well as desktops and home theater PCs. To a certain degree, Bazzite is built for the experience I'm trying to achieve. However, at this point in time, NVIDIA GPUs are not supported. Well, technically it does work, but not without sacrificing a large chunk of performance, or so I've read. My goal was to get the best performance out of my machine, so I didn't give this a try, but I still wanted to mention it as it's a great project to keep an eye on. Alright, time to start in the chronological order, as in the power on sequence. The idea is as follows. I want the PC to turn on when I turn on the controller. Both the Series X and the PS5's DualSense controllers are compatible with Windows these days and can easily be paired via Bluetooth, but that's where the problem lies, Bluetooth. From what I understand, Windows, or the PC to be more precise, won't keep these connections up or active after shutdown, which is kinda obvious, but still. Meaning it can't react to it from neither a hardware nor software standpoint, therefore the devices are essentially left in the dark. What about this sleep state then? Well, that doesn't seem to work either, or I could, for the love of God, not figure out how. I believe this is because of how Windows 11 power manages Bluetooth. There actually used to be a setting called Allow this device to wake the computer under the Power Management tab in Device Manager, but it has since been removed for Bluetooth devices under the premise that modern PCs are smart enough to figure this out by themselves. This might actually be true, and if PCs resemble their owners just like dogs do, then it would actually explain why mine is so stupid. If you're curious, in command line you can type in powercfg, then -device query, and then wake_armed, which will give you a list of peripherals that have that power. None of the Bluetooth devices I tried worked though, including keyboards. So how are we going to trigger the PC via Bluetooth then? Well, we don't. We're going to use a 2.4 GHz dongle instead. There are a few options for this, all of which involve money, unless you have one of the now discontinued official Xbox wireless controller adapters for Windows, and of course, a compatible Xbox controller. This was released during the Xbox One era, before the controller switched to Bluetooth. I unfortunately couldn't get a hold of one in time, but there are several listings on eBay. Alternatively, you can get a third-party one, but be careful, as I've read reports from other users that sometimes it's just a Bluetooth dongle in disguise. Not this one though, this one from a company called Axfee, or however you pronounce that name, which I found on Amazon, immediately got recognized as an Xbox controller adapter in Device Manager, and after double checking its wake privileges and giving it a try, I can confirm it works. By the way, if you didn't know, Xbox controllers can actually be paired with 2 devices at the same time. In order to switch to the second profile, just double click on the pairing button and then hold to pair with the second device. You can then just switch back and forth by double tapping. This way you can have it remain connected to your Xbox and your DIY Xbox. If you don't own one of Microsoft's best hardware designs ever, there's also the option of buying an entirely different controller, one that ships with a 2.4 GHz dongle. For example, the Razer Wolverine V3 Pro, or a much cheaper alternative such as the 8BitDo Ultimate 2.4G controller. I can't speak for the 8BitDo, but the Wolverine worked just as well, with it showing up in the power config just like the adapter. Of course, if you have a keyboard or a mouse that also uses a 2.4 GHz connection, you don't need any of this, but my goal was to have just a controller in the living room, just like with the PS5 and the Xbox Series X. Before I wrap this chapter up, there's one last way, and that is using a smart plug. If you got smart or dumb home appliances, you might be familiar with these or similar plugs. They essentially allow you to control devices by giving or cutting power to them. If I set AC back to always on in my BIOS, the PC will power on when the plug is activated, thus also remotely turning on my PC. It's not as elegant as the controller by itself, but it might still be a solution for some, and probably more energy efficient as the PC is taken from the grid entirely. By the way, I made a whole video about power consumption and how you could potentially save some money with these. I have to warn you though, it's about 2/3 too long. Lastly, there's also Wake on LAN, which will trigger the PC if a signal is sent to it via the network. However, the controller method is exactly what I wanted, so I didn't look into this any further. Alright, that should cover the power sequence. Time to move on to Windows shenanigans. The goal in this chapter is to get Windows to remove any password requirements after boot or waking up from sleep, so the system can go straight into the desktop where Steam's Big Picture mode is waiting. I also have one other Windows-related controller tweak I would suggest, but I'll get to that in a minute. I'd strongly advise against doing this on a work or school computer, or any system that has access to sensitive data and is in an environment where unauthorized personnel may have access to it. In order to remove any barriers after wake, we have to disable any PIN or other security checks, which you can do in the sign-in options within settings. But doing this just for the sleep scenario might not be enough. Sometimes the PC will restart or shut down completely, because of lovely Windows updates or because it crashed. In those situations, you might dread at the thought of having to reach for the keyboard. I know I would have, which is why I wanted to disable the login after a boot as well. For this, you have to make sure that you're logged in using a local account, which you can see in the settings page on the top left corner. If not, just click on it and sign out of your Microsoft account. Mind you, depending on your needs, this might affect other attributes or software, so make sure you don't need this. Next up, open the Start menu and type in regedit. Right-click and select Run as Administrator. Then navigate to HKey Local Machine, Software, Microsoft, Windows NT, Current Version, WinLogon. In there you need to find 3 values. First, default username and default password. If you don't see these, you'll have to add them. Simply right-click somewhere empty and select New String Value, and name it either default username or default password. For both of these, type in your respective local Windows credentials. It may feel a bit weird to see certain values clearly readable, so again, don't do this on a machine someone may have access to, and also, don't reuse passwords. The last value to check is Auto Admin Logon. I already had this, but just in case, you can add it as a new string as well and set it to 1. Restart your PC and congratulations, you now left your doors wide open. But you also got closer to becoming a true couch potato, and that is arguably much more important. During my search for a solution to this, I also came across one Reddit post where, additionally to the login, someone managed to replace the entire Windows shell with Steam itself. Meaning you won't see the Windows desktop in those dreaded few seconds before Steam launches. However, reading up on this, it seems to be tied to certain risks, especially when trying to get it back. But since I am most of the time waking the PC from sleep, I won't have this issue anyway, so I left it as is. Lastly, let's set up Steam to launch on startup if you haven't done so already, which you can do by going into the settings and enable Run Steam when my computer starts, as well as Start Steam in Big Picture mode. That's pretty much it. There's one last Windows related tweak you may want to undertake though. If you connect your Xbox controller for the first time to Windows, you will notice that when hitting the crest, you will get the Xbox Game Bar overlay, which incidentally conflicts with the one from Steam. In order to disable this, simply go to the settings, select Gaming and uncheck the Game Bar option. So, to summarize, if the PC now boots up or wakes from sleep, it will then automatically log in and launch Steam in Big Picture mode. That brings us to the final chapter, the fascinating world of HDMI CEC. If you didn't know, CEC stands for Consumer Electronics Control and is a standard that allows HDMI devices to talk to each other and control each other. I believe most modern TVs, AV receivers, as well as gaming consoles all have this. For example, if I turn on my PS5, it will also turn on the AV receiver and the TV, select the appropriate HDMI ports, and it's game time. But for PCs, this unfortunately doesn't work, because as far as I could figure out, no GPU on the market, neither from Nvidia, AMD, nor Intel, come with HDMI CEC. So how do we circumvent this? Well, with the help of one of these. This is an HDMI CEC adapter from a company called Pulse 8. It basically takes the HDMI signal from your PC, garnishes it with commands that you can define, and then sends it to the receiver or other connected devices. The adapter is powered by USB and simply plugs into the back of your PC while passing through the HDMI signal. It's a little ugly dangling around there, but not as ugly as the USB mini port it uses. Jokes aside, this is perfectly fine, as I doubt anyone will plug and unplug this frequently, and behind the PC nobody will ever know that we're using a USB mini in 2025. It's not the only limiting part of this adapter though. It only supports 4K signals up to 60Hz, meaning high refresh rate gaming, which is one of the benefits of a high-powered PC, is out of question here. But let's get back to the setup. After it's been plugged in, it's time to download the necessary drivers and libraries, which Pulse 8 neatly provides as a convenient Windows installer on GitHub. Once installed, you can navigate to the program files and launch the CEC client. This will open the Windows command line, which, depending on your prior experiences with the Matrix, might feel a bit daunting at first, but fear not, for our use case it'll luckily not get too complicated. As you can see, there's a lot going on here, which is super fascinating and proves that the dongle is working. What we see is all the communication happening between the different HDMI devices. For example, if I turn up the volume using my Apple TV remote, I can see it happening in real time, which is super cool. There are also two command line files included in the same folder that either turn the TV on or off and are a great way to test if sending commands also works. But we want to do more than just power on devices. We want to switch to the right ports for the PC, and for this we need to send a specific transmission command. This has to be in the form of an echo, TX, and an accompanied grouping of numbers separated by a colon and ending with a pipe and CEC client -S. But the difficulty is finding the right code. Theoretically, you should be able to see it while monitoring the signals and switching to your preferred source. For me, however, this never worked. Even after filtering for transmissions, I could never spot it. However, after some soul searching, I found out what the numbers actually mean, and I'm going to try to explain this as best as I can, without fully understanding it myself. The first pair targets the destination device, in my case that is the AV receiver. So I opened up the command line again and navigated to where the CEC client file was and typed in echo scan pipe CEC client -S-D1. This gave me a list of all the connected devices, amongst which was also the AV receiver with the assigned number 5, meaning the first pair in the group of numbers is 5F. The F is just a placeholder from what I understand. The second pair in the cluster tells the destination device, so the AV receiver, what we want to do. In our case, we want to switch the active source, which according to the website CEC-O-Matic is 82. The third pair was the most difficult to decipher and is the physical address of the devices that need changing. From what I figured out during a blind firing scenario where I shot random numbers through the command line using my remotely connected MacBook Pro to the PC, the first number appeared to be for my TV's HDMI ports, while the second one was for my AV receivers. The last pair is just padding as I understand and can be left at 00. With this working, it was time to wrap things up and get it automated. The goal, just for clarification, is that this is triggered when the PC turns on or wakes from sleep, so it tells the AV receiver to switch the HDMI ports to the PC. In order to achieve this, we must first get these commands into an executable format, and being inspired by the command line files that came shipped with the Pulse 8 library, I opted for this as well. First, I added the power on command I stole from the Pulse 8 library demo files just in case everything is off during a boot scenario. Since both take a while before they're fully operational, I also added a 10-second delay, which seems to be just enough time for firing the commands to switch the input sources. I saved the file in my Documents folder and fired up Windows Task Scheduler, which I didn't know existed before making this video. In here you can schedule, well, tasks that fire on your triggers of choice. It kinda reminds me of Apple's Shortcuts app, but a little less friendly, but way more in depth. I created a new task which is triggered by an event, in particular system and then power troubleshooter with the event code 1. This should cover waking up from sleep. The final step was to add the file as the action to be executed for both, and then save everything. I finally had the setup I always envisioned. With the hit of a button on my controller, the PC wakes from sleep and automatically launches into Steam's Big Picture mode. Windows Task Scheduler then triggers my command line file, which sends the appropriate HDMI signals to the AV receiver and the TV. Both turn on and switch to the corresponding inputs. Everything just like a gaming console. I absolutely love this, and I have no idea whether or not I took the easiest route or a convoluted mess I brought upon myself for not knowing any better. But it's working, and it has been working very reliably for the past months, so I'm quite a bit ecstatic about this. Setting the PC to standby is super easy too, by the way. Steam has a number of power controls with suspend putting the box to rest. I didn't add any further automation for this, as I most often will continue to do something else after playtime is over, but you could also add shutdown automations using the same methods as shown. Setting this up has been a lot of fun. In the past, PCs were heavily confined to a desk, but for quite some time now, mostly thanks to Steam, have made their way into a lot of new areas and form factors. The times are a-changing, if you will, and with more and more console exclusives now also being available on PC, this is becoming quite a compelling alternative. It's by far the most high-end gaming experience you can get at the moment, visually speaking of course. But you don't need the biggest and baddest system for this. Theoretically, this should work on any PC, meaning lower-powered machines can be converted into gaming consoles just as well, running less demanding titles but giving you the same couch potato experience. Or have a tandem system in play with one of the many PC gaming handhelds available these days, giving you the Switch Pro experience you've always been waiting for. But I've also been wondering if it's finally time to give PlayNight a shot, an alternative game launcher to Steam. As much as I love Steam and its Big Picture mode, it does feel and behave a bit finicky from time to time. Let me know if you'd be interested in a third visit to this subject, and if you would consider doing something similar, or have done so already. Maybe this is all common knowledge again, and I just didn't know. Anyway, thank you so much for watching, and see you in the next one, where it's back to keyboards, one that really kicks. Bye.